So this video we're going to be talking about solving systems by graphing. So it is one little part of a range of um, ways that we can solve systems, and it's one little part of the main topic of systems of equations. So when I talk about systems of equations, a system of equations basically are two or more equations that we're going to look at one time. And we're going to solve them today by graphing. So you're going to see in like the instructions to your problems, it's going to say find the solution. So what does it mean to find the solution? Well, remember when we were talking about linear equations? They formed a line, obviously. So like let's say we had a graph that looks like this, and we had a graph that looked like that. So a solution means where the equations intersect. So this right here, that coordinate, whatever it may be, this may be like 5, 1 or something, that would be a solution to the system. So it also gives you the x and y values that work in both equations. So there's plenty of different coordinates that would work for either one of them, but most of the time there's only one of them, one point that will work for both equations. We'll get into special systems where there's lots of them or none of them, but just for today there's going to be one coordinate that works, where only that one point works for both of the equations, and it's where those graphs intersect. So we're going to warm up a little bit by just telling whether the ordered pair is a solution. So is this the intersection of those two graphs? And basically all we're going to do is plug it in for both of them and see if it works. So I need to plug in 4 for the x value and 1 for the y value and see if it works for both of them. So plugging in 4 for the first one, I have 4 plus 2 times 1, and we're going to see if that equals 6. Well, 2 times 1 gives me 2, and 4 plus 2, does that equal 6? Yep, so that one works, so we know we're good. So I'll put a little check mark there. X minus y equals 3, so let's see if 4 minus 1 will give me 3. And 4 minus 1, yep, does give me 3, so this one works out well. Now it needs to work for both of them to be a solution, so this one is a solution. Okay, so if it didn't work for just one of them, then it is not. It needs to work for both of them. Taking a look at this one, let's see if negative 1, 2 works for both of these equations. So for the first one, we have 2 times negative 1 plus 5 times 2. See if that equals 8. 2 times negative 1 will give me negative 2. 5 times 2 will give me 10. Remember your order of operations. Make sure to multiply first before you add them together. So does negative 2 plus 8 give me 8? And that is yes, so this one is good. Let's see if this one works for the next one. So I have 3 times negative 1 minus 2 times 2. And I'm going to see if that equals 5. Again, do your order of operations, do your multiplication. So negative 3 and a negative 4. Does that equal 5? That one doesn't work out. So this one is gone. So if it doesn't work for just one of them, we know it is not a solution. So if only one of them works, or if they both don't work, then it is not a solution. So this one here, let's see if 1, 3 works for both of the equations. So we have 2 times 1 plus 3. Does that equal 5? No, 2 times 1 gives me 2 plus 3. Yep, that equals 5, so that one is good. The next one here, we have negative 2 times 1 and plus 3. Does that give me 1? So negative 2 plus 3, that gives me a 1. So yep, that one works out. This one is a solution. Okay, so let's get into what we actually wanted to accomplish in this video, and that is solving systems by graphing. So the problems before were just seeing if we're given a system that if that point was the solution for them. Here we're actually going to find that solution. And we're going to do it by graphing. So we have y equals x minus 3. So let's just graph that. Remember your slope-intercept, the number on the end is your y-intercept, so negative 3. And then use slope to plot the next point. So it's got like a 1 or a 1 over 1. So from that point we go up 1 over 1. And you might want to use a ruler because you have to be pretty precise when you graph these. So there's that line. And the second equation here, let's graph that. I have a point at negative 1. And I'm going to go down 1 over 1 because that is my slope. So down 1 over 1 with this point right here. And here is my graph for that one. Now you notice that where do they intersect? They intersect, boom, right there at 1, negative 2. So that coordinate is my solution. So the next one here, let's graph this. So the top equation, we have y equals 1 half x. So notice how I don't have a y-intercept number, so I can treat that as like a plus 0. So I have a y-intercept of 0. And I use slope to plot the next point, so we go up 1 over 2. So there is my line. And the next equation here, I have a y-intercept of 3. Use slope to plot the next point, so down 1 over 1. So like this. And right here is my line. So where is that solution? Right here at 2, 1. All right, the next one here. So this equation looks a little backwards. I got the y on the right side, but that's okay. I can actually just flip-flop the right side and the left side around. So I can just treat that as y equals negative 2x minus 1. Looks a little nicer. So y-intercept of negative 1. So it'll be about right here. And a slope of negative 2, so I gotta go down 2 and over 1. So about right there. There's my line. And the next one, x plus y equals 3, I need to get y by itself on one side. So let's just subtract x on both sides. So y is going to equal a negative x plus 3. So we start at a y value of 3. I go down 1 over 1 to right here. And this will be my line. So try to make the most accurate graph as you can. Now this one's a little hard to see, but the intersection is actually right here. So what coordinate is that? That is a negative 4, 7. And that is my solution.